In this video, I'd like to look at trigonometric identities proof style questions, a question that would be worded show that something is true or prove that something is true. Essentially in questions like this, I give you an expression equal to something. So this one was equal to sine cubed x, or this one was equal to 1 minus cos 2x. And they want you to basically turn the left-hand side of the expression into the right-hand side, so to prove that those two things are equal, or to show that they're equal. These questions are not particularly popular among students, and part of the reason for that is, well, other than the fact that they're very difficult, is the fact that they're never the same. You know, there's no standard method for these. And when students come across problems where there's no standard method, it can be a little frustrating, right? Because it takes experience and a little bit of insight. But in this video, rather than just going through these problems, I mean, I am going to go through them, but rather than just go through them, I want to share a couple of tips in terms of strategy. So I would say that 90%, if not more, of these problems contain a sine 2x term and or a tan x term. The sine 2x formula, the double angle formula, is on the formula sheet, and the reason why they choose the sine one rather than the cosine one, there's only one sine double angle formula. For a cosine 2x, there are three formulas. If you put a cosine 2x into one of these problems, it's very difficult for students to pick out the correct formula. It would be difficult for me, in some cases, to pick out the correct formula. So basically, if you see a sine 2x, it is a no-brainer that you should just change that using the formula sheet. You might even get marked for that already, but look out for that because it's almost certainly going to be there. The same with the tan x. If there's a tan x, no-brainer. You're changing that to sine over cos, which is one of the identities that's not on the formula sheet. So scanning our original problem here, there's a sine 2x, so just go yourself, right, no-brainer, sine 2x, changing that to whatever's on the formula sheet, which is 2 sine x cos x. Only make one change per line, right? So you're just changing out that term, not doing anything else, but that is going to be the key to getting going in these questions. Once you make a change, look for any simplification, because often after you change something, the algebra, the structure of the algebra then changes. So notice that this fraction now has got a 2 on the top and the bottom, so we could cancel those. It's got a cos x on the top and the bottom, so we could also cancel those. So that's going to leave us with sine x minus sine x cos squared x. One other tip, a second tip, apart from looking out for the double angle or the tan x, look for the other, or remember that in general, you're going to use one of the other trig identities. So the other identities are sine over cos equals tan, or sine squared plus cos squared equals 1. So taking for a moment that second formula, so sine squared x plus cos squared x equals 1, just keep in mind that this formula can be rearranged, and it's usually the rearranged form that we use. So for example, here we've got a cos squared x term. We don't have a sine squared plus cos squared, we've just got a cos squared. But if we rearrange this formula for cos squared x, we would get 1 minus sine squared x. So that's another thing to look out for in these, pulling in one of the other trig identities. If we then go ahead and replace that term, remember to keep everything else the same. So I'm not changing those, only the cos. I'm changing it into 1 minus sine squared x. So I'm taking this cos out, replacing it with this guy here. So bracket, need a bracket because there's two parts to this expression. So bracket 1 minus sine squared x. And that gets us well on our way. And the rest is just basically going to be algebra. I'll just quickly finish this one off. So sine x, now we're going to expand the bracket. Sine x times 1 is just sine x again. Minus minus makes a plus. Sine times sine squared gives you sine cubed x. And then these two guys here would cancel to leave you with just sine cubed x. Not too worried about the answer here. I'm more worried about the strategy. So looking for the double angle, looking for simplification, looking to use another formula. This one here, again, no-brainer, that the sine 2x should be made into 2 sine x cos x. If you see a tan, it's pretty much also a no-brainer. You're going to use the other formula from the formulas that are not on the formula sheet, so this one and this one, to change the tan to sine over cos. So you probably, again, already got a mark for that. Now you're just looking for simplification. There's a cos here on the top and one on the bottom. So they're going to cancel. That's going to leave you with 2 sine times sine, which is 2 sine squared x. This one is a little bit more difficult to finish off. We were trying to get to 1 minus cos 2x. So different ways you could finish this one off, but on the formula sheet, one of the formulas for, let me just put it here, one of the formulas for cos 2x says that cos 2x is equal to 1 minus 2 sine squared x. Okay, now this one is on the formula sheet. If you rearrange that by taking the negative 2 sine squared term to this side and taking the cos to that side, you would end up with positive 2 sine squared x equals 1 minus cos 2x. Meaning we can then just take this, which is here, and replace it with that guy there. So that's going to give us, I should really have some equal signs in here, that's going to give us 1 minus cos 2x. And that's the final form. But again, I'm not too worried about the final form. I'm worried about how do we get going in these questions, which is to look for the double angle, look for the tan, and then substitute those into your expression. Tricky questions, but I hope those little strategy tips maybe help.